So far we have seen how we can write a lambda expression for a case where our abstract method is taking no argument and returning nothing. Then we saw how we can rewrite the same expression for a function that takes one argument and returns something. Now let's talk about the third case, where our interface method is taking two arguments. Let's say I have an interface called calculator and its calc method takes two arguments and returns a single value. So to write a lambda expression for that case, I'll do as I've done earlier. I'll begin by writing the name of the target type, which is calculator. And I'll take the parenthesis, write the operator, and here inside the parenthesis, I'll specify the number of parameters, which in our case, 2. So let's say I'll write n and m. Now it's up to me what kind of operation I want my lambda expression to perform on those two values. Because interface has only specified that you must take two value and return one value. Now what you want to do with those two values, that depends upon the implementation code. So let's say I just want to perform an addition of the two values, n plus m. That's it. And let's take different cases of this thing. Here I want to perform the subtraction. Here I want to perform the multiplication. And here I want to perform division. If you can notice, the compiler has only asked me to change the name of the object, not the name of the parameters. Why? Because the scope of those parameters is limited to the lambda expression in which they have been defined. But the scope of the object is within the enclosing block, throughout the enclosing block, where we are using the lambda expression. Now print these values one by one. Let's see. obj2.calc, and the value that I want to pass are 10 and 20. Let's repeat this thing. So I have 4 different operations on the two values that we are passing to a single abstract method, and those operations have been decided by the lambda expression. It's up to the lambda expression, the implementation code, to decide the kind of operation that you want to perform. So let's see how this all is going to work. Let's run it. So we can see it is performing the addition on the 10 and 20, which is 30. Then it is subtracting 10 from the 20, so it is of course minus 10. Then it is performing a multiplication, 10 multiplied by 20, and then it is dividing the 10 by 20. So we have used a division operator, that's why it has returned 0. If I would have used the modulus operator, the result would be a bit different. So this is how the lambda expression with different arguments actually work. And whatever we are using so far is called the lambda expression. Why? Because it's a single line expression that we are defining. But what if your code contains more than one line? What if you want to use the return statement inside your lambda expression after writing certain line inside your block? So in that case, you will have to use the blocks, like the way we use in the cases of anomalous classes. And that is what we call the block lambda. We'll see that in the next part. And in the next part, we'll also try to cover what if my lambda expression is returning an array? What if my functional interface is of generic type? In that case, how the type of my lambda expression will be determined. Now you can ask me that you said that compiler will decide the data type of my parameter. I need not to explicitly define that here. So can I do this thing that I define the data type of one parameter and let the second one to be decided by the compiler? Either you define the data type of both the parameters in time, in time, or you define, or you just let the compiler to decide it for both the parameters. Doing this is illegal because this will create a confusion in the mind of the compiler. So either let the compiler to do the whole job or either you do it by yourself. The choice is yours. That's all for this session. In the next session, we'll cover other interesting aspect related to lambda expressions.